The California-based company saw its stock market value soar from $1 trillion to $2 trillion in just 8 months this past year, fueled by the insatiable demand for its cutting-edge technology.
Nvidia CEO Jensen Huang shared a new plan about robots at a big meeting. He's shifting Nvidia from making graphics cards to focusing on robots and AI, aiming to improve industries like making things and moving goods, making them faster and cheaper. However, this push towards robots could replace many jobs, raising serious concerns. What if robots take over too many jobs? Let's expose the urgent issues surrounding AI and robots. Steering the future of AI in industry. Nvidia's venture into robotics also suggests significant investment and signals growth in the robotics market, potentially accelerating advancements given Nvidia's expertise in hardware and software for AI. Such initiatives often involve collaborations with universities, research institutions, and technology companies, which could foster innovation and development in robotics. Nvidia, with its robust background in GPUs and AI, is well equipped to develop the necessary hardware and software, from sensors and processors for robotic perception to the neural networks required for decision-making processes. However, the integration of robotics into daily life in various job sectors brings ethical and practical challenges. These include significant concerns about job displacement and privacy issues, as automation could make some roles obsolete. The broader implications on the tech industry and beyond are profound, reshaping business operations and everyday tasks. Companies and governments must collaborate on workforce retraining and reskilling strategies to adapt to these technological shifts. Nvidia's commitment to innovation extends beyond merely creating powerful GPUs. It is about leading the charge into the future of AI and robotics. This initiative is a testament to their vision of an interconnected world where AI-driven robots could become integral to daily operations. Imagine factories where robots seamlessly handle logistics, reducing human error and increasing efficiency, or healthcare systems where robotic assistants support medical professionals, improving patient care and operational efficiency. Collaborations with academic institutions and tech companies will be crucial in overcoming the hurdles of integrating robotics into various sectors. By partnering with experts, Nvidia can foster an environment of continuous innovation and address the ethical implications and societal impacts. As we stand on the brink of a new technological era, the choices made by companies like Nvidia will shape the trajectory of innovation and its role in transforming industries and improving lives. Let's move to Taiwan, where Nvidia's big ideas start and spread worldwide. The heartbeat of Nvidia's global AI revolution. Taiwan is where everything starts for Nvidia. Their key partners are based there, and together they spread their influence worldwide, shaping the future of AI technology. Today, the focus is on explaining what they do together, how generative AI impacts various industries, and their plans to seize this huge opportunity. As they explore the next steps for generative AI, they find themselves at an exciting turning point, a major reboot of the computer industry, an industry that the audience not only helped build, but is now leading into its next big phase. Before going further, it's important to clarify how Nvidia works. They are at the intersection of computer graphics, simulations, and AI. This intersection is their core. Everything demonstrated today is about simulations, grounded in mathematics and computer science. They develop everything in-house, integrating it into a virtual world they call the Omniverse. Enjoy the showcase. But this isn't the only part of the story. The heart of what has been shown involves two key technologies: accelerated computing and artificial intelligence, both within the Omniverse. These technologies are set to change the 60-year-old computer industry. Remarkably, the ideas behind today's computing started in 1964 with the IBM System 360. This system introduced CPUs, general-purpose computing, and the separation of hardware and software. Since then, big changes like the PC revolution and the iPhone have made computing more accessible. However, as CPU performance slows while data needs grow, the industry is facing higher costs, a phenomenon Nvidia calls computation inflation. To tackle this, Nvidia has led in accelerated computing for nearly 2 decades. Their technology uses CUDA to boost CPU power by offloading tasks to specialized processors that do them more efficiently. This doesn't just address slowing CPU performance, it suggests a move towards a more accelerated setup in data centers and applications worldwide. Think about traditional computing tasks that take a lot of time. By combining GPU with CPU, these tasks can be done much faster, saving both time and energy. This strategy is used everywhere, from personal computers to large data centers, turning them into AI powerhouses. But here's a challenge. Moving to accelerated computing isn't easy. It requires big changes in software. Programs must be rewritten to use parallel processing effectively. This is complex, but Nvidia has developed many libraries over the years to help this transition in fields like AI, physics, and telecommunications. For example, QLitho helps with the complex parts of chip manufacturing, and Parabricks speeds up gene sequencing. Other libraries like QOPT and QQuantum tackle optimization and quantum computing simulations. These are just the beginning. Each library and tool is designed to help fully use accelerated computing, ensuring that AI and computing progress. This isn't just about technology, but also about practical benefits in cost, time, and energy across industries worldwide. Nvidia's specialized libraries are the true gems of the company. They have a collection of 350 unique libraries that open up many markets worldwide. Recently, Google improved their cloud services by adding QDF to speed up Pandas, a popular data science tool used by 10 million scientists globally and downloaded 170 million times every month. Now, with a simple click, users can access faster Pandas through Google's Colab, seeing big improvements in speed, which they will demonstrate soon. But this isn't the only impressive part. These improvements have helped CUDA reach a tipping point and enter a virtuous cycle, something rare in computing history. For 60 years, microprocessor CPUs stayed the same, but now accelerated computing is taking over. Creating a new computing platform is hard because of the classic chicken and egg problem. Developers won't use a platform without many users, and users won't come without strong developer support. Breaking this cycle took Nvidia 20 years of hard work in creating specific libraries. Now they support 5 million developers in every industry, from healthcare and finance to automotive, making their architecture essential. However, the story doesn't end there. Due to the growing number of customers, OEMs and cloud service providers are keen to build systems based on Nvidia's architecture. This demand pushes system manufacturers, especially in Taiwan, to produce and distribute more of these systems, expanding the market and allowing Nvidia to boost their research and development. As they continue to improve application speeds, the cost of computing drops significantly, making it more affordable. For example, speeding up by 100 times can save up to 98% in costs. As they push from 100x to 200x and then to 1000x, computing costs keep falling. By cutting computing costs drastically, developers, scientists, and inventors are encouraged to create new algorithms needing more computational power. This shift lowers computing costs to the point where entirely new applications become possible. Over the past decade, Nvidia has cut the cost of computing for specific algorithms by 1,000,000 times, making it possible to train large language models with data from the entire internet, a task no one hesitates to do today. But here's the catch. This progress in CUDA has created a self-sustaining cycle. As the user base grows and costs decrease, more developers innovate, driving more demand. Nvidia stands at the dawn of a crucial era. Without creating CUDA and the rise of generative AI, none of this would be possible. The next big idea, Earth 2, involves creating a digital twin of Earth to simulate and predict its future, helping us understand and possibly lessen the impacts of climate change and other global challenges. However, this ambitious project makes significant strides each year. Today, Nvidia shares groundbreaking results. For example, a storm predicted to move north toward Taiwan this Monday could have different impacts based on its path, and their simulation tools help understand and prepare for these outcomes. Shortly, Nvidia aims to provide continuous weather prediction for every square kilometer on Earth. Thanks to AI models that need minimal energy to run, this will keep everyone informed about the weather. This achievement shows the incredible progress made. Interestingly, the presentation just heard wasn't delivered in person, but by an AI modeled after the speaker, which he programmed. This is a significant milestone. In 2012, a crucial year for Nvidia, their dedication to advancing CUDA led to its discovery by AI researchers, marking their first encounter with AI. This collaboration helped develop AlexNet, a major advancement in computer vision. By understanding the basics and potential of deep learning, Nvidia realized that deep learning could achieve results previously thought impossible with more data, larger networks, and much more computing power. As Nvidia considers scaling up their architecture with even larger networks and more data, they stand on the brink of what could be possible, setting the stage for further revolutionary developments in AI and computing. Now see how Nvidia has changed and pushed technology forward over the past decade, revolutionizing AI with groundbreaking technologies. Since 2012, Nvidia has completely changed its approach. They upgraded their GPUs to include tensor cores and developed NVLink. Over the past decade, they've introduced groundbreaking technologies like QDNN, Tensor RT, and NCCL, and acquired companies like Mellanox to enhance their capabilities further. These innovations were integrated into a new type of computer, a concept that initially no one really understood or even wanted. Despite this, when they launched it at the GTC, OpenAI, a new company from San Francisco, saw its potential and requested the first unit. In 2016, the first DGX, marking the beginning of the world's first AI supercomputer, was delivered to OpenAI. From there, they scaled up from one AI supercomputer to larger ones. By 2017, the discovery of transformers allowed them to process and learn from huge data sets over long periods, greatly advancing their ability in understanding natural language. But this wasn't the end. They built even larger systems. And by November 2022, after training on thousands of Nvidia GPUs in a massive AI supercomputer, OpenAI introduced ChatGPT. It gained 1 million users in just 5 days and 100 million in 2 months, becoming the fastest growing application ever. Its ease of use and almost magical user experience made it incredibly popular. It felt like the computer could understand not just words but intentions. Here's a personal story to highlight the importance of understanding context and intentions. When the speaker was about 4.5, he loved going to the night market. It wasn't just about the sights and sounds, it was about the people. Despite an incident where he got a scar on his face from an accidental knife cut, his fondness for the night market never waned. There's a fruit seller there who's been working for 43 years. Watching her succeed over the years, improving her cart and her life, has been incredibly inspiring. But the story doesn't stop there. ChatGPT has been a game changer. It moved beyond the typical AI focus on perception, like computer vision or speech recognition. For the first time, the world saw generative AI in action, creating coherent and contextual strings of words, and now even images, charts, and more. These outputs, or tokens, can represent anything from language to genes, weather patterns, and even physics. This ability to generate tokens extends across domains. They can generate controls for a steering wheel, movements for a robotic arm. Essentially, anything learned can be transformed into a digital output. They've moved beyond the AI era to the generative AI era. Their supercomputers have evolved into data centers that function as AI factories, producing tokens as a new form of commodity. But that's just one part of the story. In the late 1890s, Nikola Tesla revolutionized the world with the AC generator. Similarly, Nvidia has created an AI generator. Like Tesla's invention, their AI generator creates a valuable output, tokens, that are useful across almost all industries, heralding a new industrial revolution. This isn't just about storing information or processing data anymore. It's about manufacturing intelligence on a scale that integrates into every sector, transforming a $3 trillion IT industry into a tool that serves a $100 trillion global market. Their approach is scalable and repeatable, fostering rapid innovation across all fields. Generative AI models are being developed daily, and every industry is keen to integrate this new technology. For the first time, computing isn't just about retrieval. it's about generation. The future of computing will focus more on generating data that's contextually relevant and less on retrieving pre-stored data, which not only saves energy but also enhances the relevance and personalization of information. This shift is profound, impacting every layer of computing from the ground up, changing everything from how CPUs operate to how everyday interactions with technology occur. This new computing paradigm is less about pulling existing information and more about creating new, relevant content on demand, marking a significant leap forward in how technology serves humanity. Improving one's understanding of oneself changes how technology is used. Instead of commanding computers with, "Get that information for me," users can now simply ask, "Provide me with an answer." This transformation shifts computers from mere tools to entities that develop skills and perform tasks autonomously. Consider the shift from the industry's focus on producing software. In the early 90s, Microsoft's introduction of packaged software was revolutionary, fundamentally changing how personal computers were used and driving the industry forward. Now, the world is stepping into a new era with a new kind of computer that operates on Nvidia Inference Microservices, or NIMs. NIMs function within these new computer systems as pre-trained AI models capable of executing complex tasks. The underlying technology supporting these AI models is a sophisticated computing stack that manages immense complexities, including running software that supports AI functions. These AI models, containing billions to trillions of parameters, do not operate on a single computer. They require multiple computers distributing tasks across several GPUs to manage the workload efficiently. This includes various forms of parallelism, tensor, pipeline, data, and expert to optimize processing speed. But this isn't the worst part. This efficiency is crucial in data centers where throughput, or the rate at which a system processes data, directly impacts a company's financial performance. In modern times, every aspect of operational performance is meticulously measured: start times, uptime, utilization rates, and more. Because a data center operates much like a factory. The better the throughput, the better the quality of service, and the greater the revenue. To handle this complexity, AI was developed and packaged neatly within a container, a box of sophisticated software, including CUDA, QDNN, TensorRT, and Triton for inference services. This setup is cloud native, allowing scalability within a Kubernetes environment, and is equipped with management services for easy monitoring. These containers are not just functional, they facilitate direct communication via common APIs, making it as simple as chatting with the system. With the widespread availability of CUDA, this technology is accessible on virtually every cloud service provided by computer manufacturers worldwide. By downloading a NIM, anyone can interact with AI as easily as having a conversation with ChatGPT, thanks to the integration of 400 dependencies into a seamless whole. But this is just the beginning. These NIMs have been tested extensively across all cloud installations and various GPU models, confirming their robust functionality across diverse computational environments. These NIMs aren't just tools, they are revolutionary in adapting AI to suit various fields, be it language processing, vision enhancement, healthcare, or digital biology. And now consider the practical applications of these innovations. Digital humans, for instance, are becoming crucial in fields requiring rich, interactive, and empathetic customer service. In healthcare, they assist as non-diagnostic nurses, and in retail and banking, they enhance customer support, drastically improving service delivery. These digital beings are designed to be engaging, capable of conversing through text or speech, and appear incredibly lifelike, overcoming the uncanny valley, a term used to describe robotic figures that are eerily lifelike but not quite convincing. This breakthrough paves the way for digital humans to be more natural and effective communicators, enhancing their ability to interact with real humans. Imagine, in the near future, interacting with a computer that responds and acts just like a human. "Hi, my name is Sophie, and I'm a digital human here to help," might greet users in this new era, revolutionizing customer interaction across industries from advertising to gaming, even extending into personal services like interior design. This is more than a technological evolution. It's a transformative leap towards making digital interactions profoundly more personal and responsive. Next, let's look at how Nvidia is changing the way we interact with digital beings. Nvidia's vision for AI and marketing. AI will soon act as brand representatives, changing how marketing and advertising work. Allow an introduction. Ima is Japan's first virtual model. Thanks to advances in AI and computer graphics, digital humans like Ima can now see, understand, and interact with people, almost like real humans. Observing the surroundings, it's clear this is a recording or production setting. Digital humans use AI models that understand speech in many languages and create meaningful conversations. These AI models connect with another AI to animate a 3D face model, making it look very lifelike. Additional AI models make realistic human features using advanced methods, like real-time light scattering. This technique shows how light moves through the skin, making it look soft and translucent. Nvidia ACE combines various digital human technologies into easy-to-use services called NIMs. Developers can add ACE NIMs to their platforms and digital human projects, using tools like Nematron, SLM, and LLM NIMs to understand human intentions and manage different models. Riva Speech NIMs help with interactive speech and translation, while other NIMs handle facial and body animations. The Omniverse RTX with DLSS is used for the detailed rendering of skin and hair textures. ACE NIMs run on the Nvidia GDN, a network that provides fast digital human processing across over 100 regions. But this isn't the whole story. ACE works not only in the cloud, but also on personal computers. Nvidia included Tensor Core GPUs in all RTX units, anticipating the rise of AI computing platforms. This foresight ensured a large installation base for AI technologies. By embedding these technologies in RTX GPUs ahead of time, over 100 million GeForce RTX AI PCs worldwide were prepared, ready for AI applications. This progress has made PCs important for AI development, improving tasks from photo editing to interactive digital humans. Looking ahead, Nvidia expanded its data centers to support the next phase of AI, which involves understanding and using the laws of physics for AI-generated content. AI has advanced from needing a lot of human-labeled data to models that can learn on their own from large data sets. But there's more. Nvidia is now working on AI that can learn from synthetic data and computer-to-computer interactions, similar to how AlphaGo improves by playing against itself. These AI improvements are supported by new Blackwell technology, which includes features to enhance AI security and performance. Blackwell's design has the largest possible chips, connected at high speeds, and paired with the Grace CPU to handle training and tasks efficiently. Additionally, Nvidia developed a fifth-generation NVLink in a system to monitor the health of their chips in the field, ensuring they keep performing well, even in the biggest supercomputers. Recent innovations also include a highly efficient data compression system, speeding up data retrieval compared to older methods. All these technologies are part of Blackwell, now in production and set to revolutionize computing with its amazing capabilities. The amazing benefits of the latest GPU technology are clear. What once took 72 GPUs can now be done by just one, thanks to technological advancements. This new GPU increases bandwidth by 18 times and boosts AI computing power by 45 times, while only using 10 times the power. So a single unit now uses just 100 kilowatt compared to the previous 10 kilowatts per unit. But this isn't the most impressive part. When these powerful GPUs are connected together, their potential grows even more. This is possible because of the NVLink chip, which links all these GPUs to work as one powerful machine. Large language models, which have tens of trillions of parameters, need more than a single GPU or even a single node. They require an entire rack equipped with Nvidia's new DGX technology and the NVLink switch. This switch is a technological marvel, with 50 billion transistors and connections across 74 ports at 400 gigabits each, totaling an amazing 7.2 terabytes per second in bandwidth. Within this system, the NVLink switch not only connects GPUs, but also performs complex mathematical calculations needed for deep learning right on the chip. This shows the huge leap in technology represented by the latest DGX setup. Often, people don't realize the scale of what Nvidia has achieved with these GPUs, especially if they are used to seeing consumer-grade gaming GPUs. But what is here is on a completely different level. The DGX GPU, supported by an NVLink backbone with 5,000 wires stretching over 2 miles, connects 72 GPUs and cuts power use by 20 kilowatt per rack. Yet this setup still isn't enough for an AI factory, which needs very high-speed networking to connect many such systems. While InfiniBand has been a staple in supercomputing, and AI, not all data centers can use it due to existing investments in Ethernet infrastructure and the specialized knowledge needed to manage InfiniBand systems. But this isn't the toughest challenge. To bridge the gap, Nvidia created solutions that bring InfiniBand's high-performance capabilities to Ethernet networks. This was difficult because Ethernet was originally made for high average throughput, not the bursty, intense traffic typical of deep learning applications where GPUs communicate a lot. To make Ethernet suitable for deep learning, Nvidia developed a complete architecture where network interface cards and switches work seamlessly together. They used 4 advanced technologies: Nvidia's cutting-edge RDMA over Ethernet, advanced congestion control to prevent data bottlenecks, adaptive routing to manage data flow efficiently, and noise isolation to prevent interference from multiple operations within a data center. These enhancements turn Ethernet into a high-performance network that can handle AI training demands without the usual costs. Nvidia's Spectrum X800 Ethernet product delivers 51.2 terabits per second across 256 ports. Future versions, like the Spectrum X800 Ultra and Spectrum X1600, will support hundreds of thousands to millions of GPUs, preparing for the rapid growth of AI data centers. These facilities aren't just about size. They will power the generative AIs of the future. These AIs will be integral to nearly every interaction with technology, from creating multimedia content to sophisticated digital assistants in the cloud that improve their responses to provide better interactions. Let's explore the Blackwell platform, Nvidia's key to unlocking the future of AI. Nvidia's blueprint for the AI-driven industrial revolution. Blackwell represents Nvidia's groundbreaking platform, launched right at the beginning of the generative AI era, an era that the world is starting to recognize. This launch coincided with a growing understanding of the crucial role AI factories will play in what can be seen as a new industrial revolution. Nvidia has received overwhelming support from nearly every sector. Computer manufacturers, cloud service providers, telecommunication firms, and businesses worldwide have all embraced Blackwell with great enthusiasm. The team at Nvidia is deeply grateful for this response, and their commitment to innovation remains strong. As Nvidia moves through this period of incredible growth, the focus stays on improving performance and reducing the cost of training and inference, making AI more accessible for every business. The more performance improves, the more costs can be reduced, making AI adoption easier for everyone. But this isn't the end of the story. The Hopper platform was one of the most successful data center processors ever. However, the arrival of Blackwell marks a new chapter. This platform isn't just about impressive specs. It's a complete ecosystem designed to connect CPUs, GPUs, and NVLink. Each generation is designed not just as a standalone GPU, but as a complete platform that forms the backbone of an AI factory supercomputer. This ecosystem is integrated yet flexible, tailored to support various industries, from telecommunications to edge computing. This flexibility is key as it allows customization to meet the specific needs of different data centers and clients across various regions. Nvidia's strategy is simple and clear. Build the entire data center scale platform in parts and offer it consistently every year. They push the limits of technology, whether it's process technology, packaging, memory, or optics, aiming to reach the highest possible standards. But that's not all. Another major focus is software compatibility. Keeping architectural compatibility with existing software ensures that new and old systems can work together seamlessly, speeding up time to market and leveraging the vast amount of software already developed. This approach not only enhances operational efficiency, but also maximizes the value of investments in technology. Looking forward, Blackwell is set to evolve with the introduction of Blackwell Ultra next year, following the pattern set by the H100 and H200. Each new generation pushes the limits of technology, including the next generation Spectrum switch. Yet, this isn't the final surprise. Nvidia is already planning for the next platform, codenamed Rubin. While details are still under wraps, even for most employees, the Rubin platform and its successor, Rubin Ultra, are well into development. Each iteration follows the philosophy of stretching the limits of technology while ensuring compatibility. Over the last 12 years, from the pivotal moment of ImageNet that hinted at a big change in computing, Nvidia has gone through a profound transformation. The journey from the pre-2012 GeForce era to today's Nvidia shows this change. Nvidia extends deep appreciation to all partners who have supported this journey, helping shape the future of computing. The Nvidia Blackwell platform is a big step forward in the world of artificial intelligence. As AI evolves, Nvidia focuses on physical AI that understands the laws of physics and works smoothly in the real world. These AI systems need to know their surroundings and have advanced thinking skills to understand requests and perform tasks well. Robotics is growing beyond the usual ideas. While robots are often thought of as human-like, the future includes factories and products made by robots, with robots even building other robots in fully automated environments. But that's not the whole story. To make this happen, significant technological breakthroughs are necessary. Imagine a world where every moving object is autonomous, supported by AI that understands complex instructions and performs tasks in the real world. These large language models are key in teaching robots to see their environment and make smart decisions. Now, robots can learn from humans, gaining the necessary skills through trial and error in simulated environments that mimic real-world physics. Nvidia created Omniverse, a platform where this physical AI can grow and improve. Omniverse combines real-time, accurate simulation with the latest AI technology, offering a virtual space where robots learn to navigate and interact with their surroundings precisely. This platform reduces the gap between simulated training and real-world use, making it easier to apply learned skills in real situations. But this isn't the hardest part. To support these advanced robots, 3 types of computers are vital: NVIDIA AI supercomputers for model training, NVIDIA Jetson Orin, and the next generation Jetson Thor robotics supercomputers to run these models in Omniverse. This setup lets developers and companies use NVIDIA's platforms, libraries, and models as needed, creating solutions tailored to their needs. The revolution in physical AI is changing industries now. NVIDIA isn't just planning for the future, they are actively shaping it by creating specialized platforms for different robotic systems, factories, humanoid robots, and mobile robots. Each platform has computer acceleration libraries and pre-trained models, all tested and integrated within Omniverse. But the challenges don't end here. Think about modern robotic warehouses. They need collaboration across many companies and technologies. NVIDIA provides the software development kits and application programming interfaces that connect to the software industry and edge AI companies, allowing advanced robotic systems to integrate into various environments. Foxconn, for instance, is building some of the world's most advanced factories, using edge computing and robotic software to design and program these facilities. NVIDIA's technology is crucial here, with SDKs connecting each part of the ecosystem from design to operation. Foxconn is not alone. Major players like Delta, Pegatron, and Westron are also creating digital twins of their factories using NVIDIA Omniverse. These digital twins mix physical and virtual elements to improve planning and efficiency. In these virtual spaces, robots are trained to do tasks like identifying objects, detecting defects, and planning paths using NVIDIA's Isaac AI applications. But this isn't the final step. As the need for Nvidia accelerated computing grows, more AI-powered robotic factories are being built. These new factories are not only more efficient, but also pave the way for the next generation of robotics in manufacturing. With platforms like Siemens Teamcenter X and Autodesk Revit, factory planners can optimize layouts and workflows before any physical building starts, saving costs and time. Looking ahead, Nvidia is dedicated to advancing robotics in every field. The upcoming production of the Mercedes and JLR fleets shows Nvidia's full-stack capabilities, which they offer to the world to adapt as needed. Additionally, humanoid robots are set to become a major focus, using extensive data on human movement and interactions to train AI more effectively. Do you think the rapid advancement of AI in industries risks human jobs too quickly? Like, comment, and subscribe for more.